I am Atahan Kutlu. I'm a first-year student in industrial engineering, taking Physics 101. I conducted an experiment on calculating the Earth's gravitational acceleration. The aim of the experiment is to derive g by using freefall mechanics. The experiment involves dropping a ball from different heights and calculating their fall times. The equipments that were used in the experiment are a ruler with a precision of 1/10 of a centimeter, a ball, and a stopwatch with a precision of 1/100th of a second. The ball was dropped from 5 times for each vertical displacement to get more accurate results. Now I will talk about the procedure of the experiment. The first step is to use a ruler to mark a vertical plane with the height the ball will be dropped from. That could be a bookcase. The second step is to drop the ball from different heights, and then we will record the fall time 5 different times. Then we will use those different times to calculate the average fall times, and then these values will be used in displacement versus time square graphs. When an object is dropped from an initial height with an initial speed v0, the final speed should be v0 plus gt. We can calculate its traveled distance by using average speed method, and we end up with the equation you see here. Since v0 is equal to 0, when we drop the ball, it means then the h, the distance it traveled, is equal to 1/2 gt squared. Here's a table that shows the relationship between vertical displacement and fall time. Although it's hard to see here, considering h equals gt squared, their increase should be accordingly. As you can see here, each different height was tested 5 times. In the next table, the average of these values will be used to calculate g to increase accuracy. In table 2, we can see the displacement values with the average time. Here, 1/2 gt squared was used to calculate g. When we look at the g values, we can see that most of the time g was calculated to be lower than the actual value. This is probably because of frictional forces. And here is the displacement versus time square graph. This line should be linear since gravitational acceleration is constant, but as you can see, there are higher and lower values in the data points, creating oscillations. Here, the data points were used to create a best fit line. When we take the average of all the g values we found, we get 9.35 meters over second square, which is very close to the actual value, that is 9.81 meters over second square, with an error percentage of 4.68%. These errors were probably caused by air friction with other possible reasons. For example, the usage of a stopwatch can cause errors since it is hard to stop the time exactly when the ball hits the ground. Another possible reason for error is that there could be unintentionally applied forces when dropping the ball. Thank you for watching my presentation on calculating gravitational acceleration of the Earth.